Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Duckworth Jr., your math tutor. In today's lesson, we want to look at the first set of examples under finding the derivatives of natural exponential function. So in the next set of videos, we will solve additional problems, and in other lessons, we will solve problems involving the ordinary exponential function, that is exponential function with base a. So let's look at the first problem. The first problem says y equals to e raised to the power 2x. So when y is equal to e raised to the power 2x, remember we said when y equals to e raised to the power x, or when y equals to e raised to the power u, where u is any function, it means y prime is just equal to e raised to the power u times the derivative of this particular u. So this means we must rewrite the function e raised to the power u, and then we differentiate u. Similarly, we can find our y prime by rewriting this e raised to the power 2x, and then we differentiate 2x. So the derivative of 2x is just equals to 2. So this is now 2 e raised to the power 2x. Now what if your instructor asks you to find the derivative of this using logarithmic differentiation? So to use logarithmic differentiation, and one of the reasons why it's important is because most times we can have expressions with challenging powers, or we can have long products, like you will see x plus 1 times x plus 2 times x plus 3, those kinds of problems. So when you see those kind of problems, you bring in the natural logarithm method, because the natural logarithm or the logarithm will help you to open up these factors. So for this one, it will help you to bring this power down. So we can take the ln on both sides. You can also take log on both sides. Ln of y is equals ln of e raised to the power 2x. So we know that ln of a raised to the power r is equals to r ln of a. So this 2x can come downward. So it will be 2x ln of e. So remember this ln of e and 2, they are constants. The only variable here is x. So let's differentiate. To differentiate a natural logarithm, say 1 over whatever function you have, 1 over y, times the derivative of that function. The derivative of y is just y prime. Now, we hold the constant 2 ln of e. We differentiate x, we get 1. So y prime, cross multiply, y prime times 1 is y prime, and then y times this numerator is 2 ln of e y. What is ln of e? We know that ln of e is equals to log of e base e. Now, log of e base e, if you want to write this expression in exponential form, assuming that this is x, e raised to the power x is equals to e. So it means, what value can x take that will give us e? X can only take 1. So when x is equals to 1, e raised to the power x is equals to e. So based upon that, when the base of the logarithm is e, and the argument is also e, is just equals to 1. So the ln of e, which is also written as log base e of e, is equals to 1. So we have y prime to be 2. This is 1. So it's just 2y. What is y? From the beginning, y was e raised to the power 2x. So you see that the same answer you got, this is the same answer that we got here. But it's just that probably this one is a bit longer. So question 2 says y equals to e raised to the power minus 5x. So y prime is just simple. Rewrite e raised to the power minus 5x times differentiate minus 5x. The derivative of minus 5x is just minus 5. So y prime now is just equals to minus 5. Now we can decide to reciprocate this expression so that we get a positive right here. So it's e raised to the power positive 5x. Solve question 3. Question 3 says f of x is equal to e raised to the power 2x cubed. Again, f prime of x, you just rewrite e raised to the power 2x cubed times the derivative of the power. So 3 times 2 is 6. Subtract 1 from the power is 2. So finally, we can just get 6x squared e raised to the power 2x cubed. Question 4. So question 4, we have f of x is equal to e raised to the power 2x squared 6x, or we can rewrite it as 6x e raised to the power 2x squared. Now, there are two functions right here. You have an algebraic linear function and you have an exponential function. So whenever you have two functions being multiplied by each other, you can apply the product rule. When you have two functions being divided by each other, you can apply the quotient rule. So we apply the product rule. So the product rule says we must hold one of the function, x, and differentiate the other. So the derivative of this is just e raised to the power 2x squared times the derivative of 2x squared, which is 4x, because 2 times 2 is 4. Then we say plus, we rewrite the one that we hold on to the one that we differentiated first. So it's e raised to the power 2x squared. And then we differentiate this x, it gives us 1. So we can simplify now. F prime of x is just equal. Now if you look here in this term, this is one term, and this is another term. You have e raised to the power 2x squared, e raised to the power 2x squared. So we can factor it out. So it's 6 e raised to the power 2x squared is outside. What is left here is just x times 4x and then plus 1. So this is our final answer. So thanks all so much for watching. In our next lesson, we will do question 5, 6, and 7 and some other additional problems. Thank you and see you in our next lesson.